Hello everyone, I am thankful to the organizers for arranging such a wonderful opportunity to present our work. And we also express our gratitude to Shahjalan University of Science and Technology Research Center for funding our research. Now, I would like to share our take over the design and development of a smart wheelchair for the disabled people. So, without any further ado, I will start my presentation. In this presentation, we are going to see why the wheelchair is so significant, what are the research opportunities here, then we will see the objectives that we have tried to fulfill. After that, we will have a glance of system design and its performance. Then we will discuss our future aims and lastly come to a conclusion. Almost 15% of the global population suffer from some form of disability, of which almost 13 to 26% have severe difficulties in motor functioning, who use the wheelchair as a medium of transportation. A traditional wheelchair user constantly rely upon upper body strength for movement or assistance of another person. This creates a mental inferiority complex due to the lacking of freedom of mobility. Therefore, several kinds of research can be done regarding designing a compact, low-cost and mass-producible design, durable and energy-sufficient system, versatile mobility on various terrains, user-friendly control system, health monitoring features, security and emergency features. The objective of our research are to make a robust motorized wheelchair for both indoor and outdoor usability, designing within a viable budget, develop an easy user interface, ensure user safety, and monitor users' health. We have transformed an ordinary medical wheelchair to our smart wheelchair by installing two motors and our main module to minimize the cost. Although the design is simple and minimalistic, it is still sturdy enough to bear heavy loads. The device is still foldable, allowing convenient storage. The overall hardware interfacing is around the main microcontroller unit, which is an Arduino Mega. It is a low-cost MCU with a large number of I/O pins, ideal for projects with multiple devices. It connects most of the devices directly except for the voice recognition module, because the voice recognition process requires quite a lot of processing, and we could not spare much of the processing power from the main controller. Therefore, we are offloading the voice recognition process to a smaller secondary microcontroller. After powering on the device, all the settings are initialized. Then the system waits for the user to provide further commands. If the user chooses a drive command, the corresponding drive method is then initialized. As long as the device receives normal input and the user does not provide a stop command, the device executes the command and moves accordingly. Sometimes the user might want to recalibrate the sensor to fine-tune the sensing. To do so, the user needs to select the control that is to be recalibrated. Then the user will be guided through the entire calibration process by an interactive menu. After successful calibration, the control is then fine-tuned by that user. In some cases, the user might require assistance from another person. From the call for help option, the user location will be estimated and sent to an authorized person. In addition, a loud siren is ranged to draw the attention of people nearby. We are using a compact aluminum enclosure which enhouses all the electronic devices and integrated circuitries except the motor and charging unit, which we are calling the main module. On the main module, we have an LCD display which will show the control interface with some relevant information. Below the LCD display, we have the joystick. The user can navigate across the control interface as well as drive the wheelchair with it. The heart rate sensor is positioned below the joystick module. It can measure the user's heart rate when a finger is placed on top of it, and the result is displayed on the LCD. When the sensor notices any form of irregularity of the heart rate, it will immediately send a signal to the main controller, which notifies the authorized person with the estimated location. By using the voice commands, the user can be able to access the whole function of the wheelchair without touching the main control. The wheelchair is well capable of reaching more than 5 km per hour with an acceleration speed from 0 to top within 4 seconds. The charging rate is kept slower to ensure user safety. All of the tests are executed on ordinary pitch covered roads and by dragging some weight behind the wheelchair. We have also conducted a test on charging efficiency that shows the efficiency is above 49% from socket to wheels. The coding was done in such a manner that the joystick would respond 0.1 second after the user had given an input. No fault were detected in the potentiometer of the joystick. Therefore, we had an accuracy rate of 100%. In similar manner, accelerometer was also coded to respond. Some advanced vector method was employed to gesture control, which also yielded an accuracy of 100%. The voice module has a response latency of 2 per second and showed accuracy as low as 65% in a noisy environment. Therefore, we only employed control navigation and did not implement any driving method with voice, as it had potential to cause unwanted troubles. Our wheelchair was tested by 3 technicians and 17 general people of ages ranging from 9 to 70. The intuitive interface of our wheelchair makes it easy to understand for people of all ages. Especially, the gesture control system was found to be most easy for elderly peoples, whereas people of aging from 15 to 40 were particularly easy coping with voice control. In the future, we would like to expand our research to use more advanced graphical user interface, implement autonomous driving around obstacles, travel long distances and automatically route selecting Google Maps, incorporate more medical sensors like glucose measurement, pulse oximeter, and blood pressure sensor. At the end of our presentation, we can say that we have successfully built a reliable, considerably easy control system for everyday use, successfully implemented the smart features while maintaining the minimalistic and rigid design. The device is well equipped with medical and emergency alert system, which will surely give the user and their dear ones a boost of confidence while using it in their daily life. Ultimately, we can say that this device will give freedom and taste of self-dependency to physically handicapped and elderly people once more. Thank you everyone for your kind attention.